Here we're going to get into grade domaining. I'm looking at some drill hole data in GEMS, and it's color-coded by grade. And in my mind, I'm making this interpretation of a mineralized body that is defined by this drilling. And what I want to do, after I kind of get that idea in my head as to what the shape of this mineralized body looks like, I want to then create this three-dimensional solid that encapsulates it. So here is the process. So what I'm going to do is I think I can define a shape that pretty much captures the yellow and the orange, and if there is any red grade values. So those are the higher grade values in the deposit. I feel like making a subjective call, I can create a mineralized, a solid that captures, for the most part, those values and separates them from all the lower grade values. So I got the picture in my head, but now I need to be able to make it happen. So what I'm going to do first, I'm going to do two things. I'm going to extract all of the composites, all these values, as individual points in 3D space. And then I'm going to do that again, but in a slightly different way, so that I just have points at instead of having a point at the center of a composite, say, I'll have points at either end of a composite, so at the top and the bottom. And those are just going to be useful for clicking on. So the first step, we'll go to Workspace, extract points. And here we're going to ask a couple of questions. One, where's the information going to come from? It's going to come from the drill hole database. And where are we going to, when we extract that data as points, where are we going to put those points? And that's what's being asked here. So I'm going to go and open up this point area workspace. And this one was by default built for me when I created this GEMS project. And then we're going to give it a name, and I'm just going to call it, let's call it comp points. Okay. Here I'm going to give it a display profile, but I haven't really picked one or made one yet. There's this default one, but that's not going to work for me. So I'm going to go over here and click on that button to get me to this window, which allows me to define a new display profile. So go up here and go to New Profile. I'm going to call this, just call it Grade. And in here, what I want to do is click on this More button. Well, no, first I need to tell that what workspace this applies to. And then I'm going to go click on this More button. And here, what I'm really telling it is that I want to show these points, I want to color code these points in space by a certain value. So I'm going to click location, I'm going to click on R value for now, and remember that R value, that's where I'm going to put some important information. And then color profile is going to be grade. Click OK, apply, OK. All right, now I'm going to move on to this data tab, and I'm going to start giving in more details how, where the data is going to come from and where it's going to go to. So from the composite table in my database, I'm going to accept that. I'm going to pull from that composite table, specifically from the grade field in that composite table, pluck that out and put it into a point workspace. And I'm going to plop it into this R value field. And remember, that's the value that we're going to use to color the points. So we're going to put the grades in that field. The rest looks good, except all of that. Click OK, and I want to use all of the holes when I do this exercise. Okay, you usually have to toggle between 2D and 3D to get these things to show up. So if I hide my drill holes, you see these points. They weren't there before. If I show my drill holes, you can see that the colors and the locations are the same. So now I have my composites in this as 3D points. Let's save that. Okay, I'm going to do this exercise again, but I'm going to change a couple of things. I'm going to go again, Workspace, extract points. It's given me all the kind of the same setup, but I want to change the point area from comp points to an area I'm going to call from to. I'm going to select all this, go to the Data tab. And the only thing I'm going to change here is instead of using the middle of that interval in the drill holes as to give me the coordinates of a point, I'm going to change that to use from. So that's going to give me the point at the top of the interval. Okay, accept all that. Save. Okay, I'm going to do it one more time. I'm going to change this. So this, if I left this here, I would overwrite all the points in this point area here. I don't want to do that. I just want to add to it. I'm going to go to the Data tab and switch this reference position from use from to use to. Hit OK. Okay. Save that. Hide the drill holes again. We've got a lot more points, but if I hide the comp points, really what I've got here are the points in space that mark the top and the bottom of the drill hole intervals. And that's all that exercise is so that I can click on, I'm going to go do something else, and I'm going to need to be able to click precisely on the interface between two composites. Okay, so now what I'm going to do is orient my view like this so I can imagine a solid passing through the yellow and orange values along here. So what I'm going to do is I'm going to go do polyline, create, and then feature line. Select status line. Okay. So now I'm in this digitizing mode where I can create a line. And I'm going to create a line that connects really the top of the interval I'm interested in. Again, this is a subjective call I'm making here, but making my own interpretation as to what this mineralized body looks like. Right click. I need to select a workspace, and GEMS is automatically giving me this miscellaneous lines workspace, which is great. And I'm going to select OK on all that. I'm going to hit escape to get out of that digitizing function or feature. Okay, so I think I missed one though. There it is. I want this line to be snapped to the top of that interval. So we'll go up here and insert a point and then click on the top of that interval. So now my line is snapped up the tops of all the intervals I want. I'm going to right-click this and save. I'm going to do that again for the bottom of the intervals. I'm going to change the line type to something else just because I want it to show up as a different color. Okay, save. All right, now I've got these two lines that are connecting up the intervals I want to be included in the solid. I'm going to line up my view so that I feel like I'm looking right down the dip of this body. And what I want is I really want a plane, a viewing plane that passes straight through there. And this is how I'm going to get that done. I'm going to go to View, Incline Section, and then Plane through 3 data points. And this is a bit of a trial and error thing, but I'm going to try and pick 3 points along this line that's kind of line up in a straight line. There. That's the first one. Okay, I got lucky. That was pretty good in the first try. But you see this defines a 2D plane that passes pretty much straight down the middle, or I should say it's parallel with the dip of this mineralized body that I'm imagining. Okay, I'm going to go to the 2D view, and I need to hit this zoom to extents so it can get me back in where I'm going. Now I'm looking directly at that 2D inclined plane that I defined. I'm going to start turning things off. I'm going to hide the drill hole data. I'm going to hide these points, and then I'm going to go to polyline select manually, and just deselect one of these lines. So now I've got one. That first line I made is the only thing that's really active right now. Now I'm going to go to Surface, Create Surface by Laplace gridding, and then define grid location graphically. And I'm going to make a big box around my line, and I think here I'm going to use 100 and 100 for now. So what this is going to do, and I'll just click OK so you can see it, is it takes that digitized area and lays out a bunch of points that are 100 meters by 100 meters apart. And then it's going to then use the 3D locations of these points along the line to interpolate a surface, a gridded surface that passes through that the points I've defined on this line. I'm going to say no. I don't really like how far spaced these things are. I'm going to say no here. I'm going to do it again. If I right click, I can get to the more recent commands I've used. So define grid location graphically, make a big box around it, and then let's go to 50 by 50, accepting all the other default parameters, and that looks better. So I'm going to say yes. I'm going to select point area of all cells and click OK, and then I'm going to give this a name called temp. And click OK. All right, so now I've got all these points, and if I look at them in 3D, you can start to see what I've been talking about. These points define this surface, and that surface is doing its best to pass through the points that are in my blue line here. Okay, so let's go back to the 2D view. We're going to do that exercise. Well, no, we got to do this. I'm going to go to Surface, Create Surface from Active Data. Click OK. Usually this is clicked, and usually this is at this setting. And as you might have guessed, these are not the settings I want. I want this changed to Current View Plane, and I want this clicked off. Okay. So now I'm in the process of making a wireframe that defines the this single surface. So the workspace I want to put it to is this default tin workspace that GEMS has provided for me, and I'm going to name this. Let's call this side A, and click OK. Now, let's save that. Let's close that and don't save it. We'll go to the 3D view so we can see what happened there. So now it took those points and now it created this 3D surface. Again, trying to pass through that line I defined. So now let's make another line or another surface that tries to pass through the other line. The surface I've got here, I wanted there, but this particular view is obstructing, is getting in my way. So I'm going to actually go up here, and instead of drawing my surfaces as triangulations, I'm going to do it as projection. So that just kind of gives me the extents of the surface so I can see where it is. I'm going to go to polyline, select manually. I'm going to now select the grayed outline, which is the second line I drew, and then deselect the blue line. Hit escape to get out of this digitizing feature. Go to surface, create surface from Laplace gridding. Define grid location graphically. Big box, just as big or bigger than the first one. We'll do 50 by 50 meter grid again. Click OK. Point area of all cells, OK. And then again, change this to temp. Click the delete and replace just in case there's any data in there I didn't get rid of. Okay, so there we go. If we switch back to 3D view, we have this new grid that's trying to be true to that kind of teal line there. Back to 2D view. All right, surface, create surface from active data. Where is it? There it is. Okay. Again, I wanted to use the current view plane, and I don't want this active. This should not be checked. Okay. And this one is going to be side B. And I'm going to give it a different color so I can see the difference. Okay, now before I move on, what I want to do, the edges of these surfaces are not going to be, they're bad. I need to clean them up. So the way to do that, I'm going to go to polyline, create contour line, status line, good. And I'm going to draw a square just inside both surfaces. And I'm going to clip. I'm going to clip both surfaces to that clipping polygon. So we'll go to surface. Let's see, edit, clip, surface outside clipping boundary. Click the line I just digitized, and then click one of the surfaces. Click yes. I'm going to overwrite the original surface. Yes. Yes. Close. Close. Okay. And do that again. Clip surface. Click on that digitized line. Click on the surface I want to clip. And just accept all of that. Okay, so now what I should have, actually we'll close that, don't save it. Save the line just in case, save the triangulations. Go to 3D view, hide. No, let's keep those. And then I'm going to change how I visualize triangulations by going to draw triangulation. Okay, now I got the top and bottom surfaces of these of this mineralized body that I'm trying to define. But they're surfaces, they're not solids. I need to create this, I need to turn these two surfaces into a single solid. So I'll go to Solid, Create, and then Create Solid between two non-intersecting surfaces. And then I'll click the top one and the bottom one, and right-click to go to this command here. I'm going to name this Solid and give it a color of red. Yeah. Okay, so there's this surface I got, but it's a solid that sort of defines the mineralized body I had in my head, but it's going too far and it's just not the right shape along the edges. So here's where these composites are going to start coming in useful. I'm going to show the composites. I'm going to hide this for now. I'm going to close the drill hole data. Now I know that some of the points are in, some are out. I'm going to go to Point, Select, Deselect All Points. I'm going to go to Point, Select, and then select points inside a solid, and select this solid. So now I've selected only those points that happen to fall inside. Let's go back to a two-dimensional view. I'm going to change how I see triangulations. I'm going to go select this projections option. Okay. And then I'm going to hide point display and hide any points I haven't selected. Okay, so that looks okay. Now I'm just going to make this kind of subjective call as to how far in any direction I want this solid to extend. And the way I'm going to do that is I'll go to Polyline, Create, Contour Line, Status Line, and then just digitize around the data I've captured in that solid. Click OK. So what I'm going to do is take this big solid and then clip it to this polygon here, so my solid doesn't go wildly out in these directions. So to do that, solid, intersect, clip outside clipping boundary. Select the clipping boundary first, select the solid next, give it a new name. This time we'll call it solid clipped. And I messed that up. Solid, intersect, clip solid outside clipping boundary. Hit OK. All right, so now it's clipped. If I go to solid data, select from a list, I've got all these solids, or these triangulations. I got the two sides I built, I got the original solid and then the clipped one. I just want to see the clipped one for now, so I'm going to select this and hit OK. Change how I view view triangulations from a projection view to a triangulation, and then get into 3D. And then show my drill holes again, so I can start to see this wireframe now. I feel good that it captures the mineralized body that seems to be defined by the drilling. Okay, and that's how I go about making a triangulation, a solid that captures a mineralized body that has more or less a tabular shape to it.